Good afternoon, good evening, wherever you join us. Thank you for joining. Thank you for watching and participating in today's live stream. Today, I'm super excited and happy to have Xixing Wang with me. And hi, Xixing, how are you doing? Welcome.
Hi, good. Thanks,
Good.
Alex.
Thanks. Cool. Good to see you again. If you followed this channel for a while or our streams, then you might have seen Xixing taking part in the life sciences workshop we hosted end of last year, so a couple of months ago. If you follow the Neo4j world, you probably read one of his many great blog articles. So I'm constantly amazed, Xixing. It's great. I mean, I pinged you about this. You posted I think yesterday or the day before or something, this week at least, another amazing article. Maybe we can talk about that as well a bit later. But it's really great how many great texts you write, and how much good and interesting pieces you publish. So that's really great.
Thank you.
Shall we? Before we dive in, maybe I'll do a quick shout out to something that's coming up, and then we dive in right into the topic. I wanted to give everybody the opportunity or a reminder basically of Graph Connect that's coming up. So it's now in 2 weeks time, so really close. If you are on the fence of going, and obviously if you can still make it there, depending where you're located, we have a 50% discount code for the community available. So I'll share that in chat in a second. So that is available for everybody. And it's going to be a fun 3 days. So we have a training day on the 6th. So I'll can quickly give you a short, really brief update overview of these are all the trainings that are taking place on the 6th. So data management, cipher query tuning, obviously graphs in graph database, more like a general overview session, implementing graph models. Then here, Neo4j and Vertex AI hands-on lab. So that's very advanced. I need to scroll down a little bit further so you can see it. Actually, it says beginner here. I thought it's more advanced. Well, then it's not. And then other things. So that's taking place as well as the general agenda. You can have a look here and see. It starts at 7 a.m. in the morning with registration, and then we have sessions from 9 on 2 days, the Tuesday and the Wednesday. So I'm pretty excited about that. I'm looking forward to Graph Connect. Looking forward to meeting the community, to talk to people, to hang out, and to chat. So if you're there and if you see me, obviously, please say hi. Yeah, I'm excited. So it's going to be good for the first time again to meet in person, right? So cool. Let me post that code in chat, and then we can dive in, Xixing, with the actual topic, Doctor.AI. Let me put up that post here in the screen here. This is from last December, I think. Yeah, December it says here. I think this is when it started. This is when I first read about it. I think it's now almost a little series in your blog. You have a couple of times you touched base on Doctor.AI and on the chatbot. Maybe before we dive in, though, do you want to give the audience a few words about yourself, who you are, what you do, and all that?
So yes, of course. Thanks, Alex. My name is Xixing Huang. I am a German bioinformatician. Currently, I am working in Shenzhen in MGI as a senior bioinformatics analyst. In my free time, I take part in this Singapore data marathon last year, and a team with 4 other Neo4j engineers, and then with the support of Maruti, Joshua, and Daniel, then we submitted our solution. So it's a virtual healthcare chatbot actually. So as you can see in the article that we have the data from the EICU, and at the beginning we just built everything on AWS. So with the Lex and the Lambda and then the EC2, and the backend is Neo4j. So the Neo4j hosted a knowledge graph actually. So it's like a patient journey. So because the data was the EICU data, it is a data set collected between 2014 and 2015. So it is an ICU data set. And we just imported the patient's information and some of their vitals and diagnosis and treatment and so on into the graph. And then because it is a very complex data scheme, so it is even hard for the programmers to write Cypher to go through it. So then obvious, it is very hard for the layman, so the majority of the population who cannot program. And let's not forget that many people cannot even write or read, or some of them cannot see very well. So it will be a very like a privilege only reserved for the few who can program to use it. So then we think everybody needs a doctor. Everyone needs medical care. So how can we democratize all this information to everybody who can program or not? It doesn't matter. So what is better than making a natural language chatbot? So as long as he can speak in English at the time, he should be able to query this database. So it was the beginning of the chatbot project, Doctor.AI.
Yeah, that's super cool, and I think that's where all this technology really comes now into play to make it more accessible, to make it easier. Like you said, I mean, if you just need to say something into a chatbot and then you can get help, it makes it all very much accessible. Which yeah, I don't need to repeat you, but it's a great thing, and we have all these various other things taking place at the moment with fitness trackers and e-health. I read an article a week ago or so about all these new systems that are very valuable if you use them right to keep track about what you're doing. And if you feel like if you don't feel well or something like that, I think when Apple announced, I think, the Apple Watch a couple of years ago, they implemented this. Oh, you seem to be not walking straight anymore, and that could hint into towards a stroke or something. So it's really advanced nowadays, but still on the other side, it's so far away for many people, because obviously not everybody can afford an Apple Watch. But yeah, if that gets closer, and then obviously I think maybe you can talk to that as well. Is many people live in remote areas and don't have access directly to a doctor sometimes, and if then a chatbot like this is helpful and can say, okay, yeah, this could be a path of treatment, and give them access quickly to some sort of help without them having to go to a doctor that could be sometimes far away, is obviously also helpful with the daily lives of many people.
Yeah. So so the positioning of this app, it is more like a info tech. So it's not a replacement for a real doctor. So for example, during the COVID-19 time, so in the lockdown, many people cannot go to the clinics, but many times you just want to know some small pieces of medical information. So you don't need to go to the doctor to know, what it is COVID-19 or so what does it mean to, to take this exercise. So, but in Google, you are going to see a lot of results that of various quality. So you don't know
Yes.
whether the medical advice there is authoritative. So is it correct? So there is no like a central authoritative source of information, and most of the people will just say, okay, I will just look at the first Google hit, and but that was dangerous. So
Yeah.
so we will think, so why don't we just build a very reputable database with reputable sources so that people can trust the information, and also the information should be updated frequently. So it's not like a static data source from 2015, but it should evolve. So later on, we also build an MLP pipeline that try to capture the new uh, information and then import it into the database. So then people can really like ask for the newest development in the medical research world, so they don't feel left behind. So and as far as I know, for example, the AWS Alexa will try to avoid this kind of question if you ask Alexa for medical advice, because AWS will say, yeah, please consult your clinicians or your physician, because I can imagine that, because it is an ethical issue too. So how can you um, take the responsibility if your chatbot gives something ill advice? So maybe things that will really lead to death. So it is very difficult for the cloud vendor or the developer to take up this responsibility. But the technology that advanced so quickly, however, if we don't use it for medical, instead we just refer them to, please ask your doctor. And sometimes I think even doctors need a hand or two from such an information system, because many patients, they suffer from late or delayed diagnosis, and that actually make their ailment worse. So because it delays their treatment, and it is not that the doctors, they are incompetent. It is just sometimes they cannot know everything. Some very rare diseases, but if we have a chatbot that can, for example, answer some of the very simple questions. For example, if we have a list of symptoms, and can the chatbot give us the possible causes, then we can look into all these possible causes, and then the patient can also self-examine whether I also have the other symptoms that listed in the chatbot, and then it will help. So it is not a replacement for the human, the deep medicine. So, but it is like we all want to have a very comprehensive, like a very objective, information source. And I hope that we can build something like this in a very cheap, open source manner, so everybody can reproduce it, and everybody can even use it for some other purpose, not necessarily for medical chatbot in this case. If you replace
Okay.
the database,
Yeah. Absolutely agree. There's so much out there, and so much not very useful information that doesn't help you a lot. I always feel like if you Google for some kind of if you don't feel well and you Google your symptoms, you probably have a terminal disease and you will be dying in 2 days.
Yeah.
But you know, it's probably just a cough, but it could be something in between, or actually could be that. So yeah, I think that is with this, you know, variety of diseases and broad spectrum. It's like I said, it's also very hard for a practitioner, for a doctor, to decide what it is. And if some AI tool can help in that way, it's like a double win in that sense.
Yes.
So I don't know. Do you want to show something now
Yes.
in terms of you know, the Doctor AI or some
Yes.
yeah.
So let me share my screen.
Hmm.
So I click on here.
While
Yes.
Xixing looks for that button, if you have any questions, anything is interesting to you, and you wanna know more, and you're watching this live, obviously, type it in chat. Let us know. We have some time. We can potentially dive in one or two questions. So yeah,
So
it's
can
always
you
the point of
see?
making this interactive. Yes, I can see. Yeah, let me
Okay,
pull it
you
up.
can see the script.
Yeah.
So here is the PowerPoint presentation I have given in the KGC 22. So it's just very brief, very good, very short introduction of what's in this chatbot.
Yep.
So as I said that let's don't forget a large proportion of population who can neither read nor write, let alone program, especially in cipher, a very specific language. And then there are also people who are visually impaired, so they don't see very well. So they need something that do not need to type. And plus, voice is faster than typing. And there are situations that you cannot use your hands, for example, in the surgical rooms or some dust-free labs. So, and also that is for some specific reasons, but in general, in the patient-doctor relationship, the patient are always in this information asymmetry situation. So they know less, and the doctors know more, and that's the reason why the patients go to the doctors. Otherwise, they don't need doctors. But in this situation, it also has leads to a conflict of interest because it incentivizes the doctor to maximize their profit, and then the patient's health maybe is in the second place, and also it will erode the trust in the doctors. So we need to level this kind of asymmetry play field. So we want to give the majority, the patients, access to good information, medical information, but not only just give them the literatures, the research papers, but also we need to simplify those difficult concepts so that they can understand. It makes no use if I just tell the patient a series of gene names and then drug names, but we need to tell them in plain English what is going on.
So
So,
sorry to interrupt, Xixing, but should we be able to see something which it still says loading
okay.
on my screen here?
So
Um,
now, is it possible?
no, I see. I think I see your browser. I think it went into presentation mode, but I see your the browser where it's
Okay. So
maybe
may I,
the wrong window.
let me see very quickly. So it
Yeah.
was uh, so but this now, so I don't
Yes.
go to full screen. Okay.
Yeah.
So this is
This works.
the,
Yeah.
yeah, this is the interface of the Doctor.AI. So as you can see on the left panel, if I ask Doctor.AI with like questions about HIV, and the Doctor.AI can return me the answers that it fetches from the Neo4j backend. And I can ask what kind of pathogen that causes HIV and what kind of drug can we use against HIV. And also I can ask what kind of gene causes certain heterotypic, so genetic disease. So I get the answer. So this is the interface. The architecture is actually quite simple now. So let's begin from the right-hand side. So both the doctors and the patients can ask questions, and they can ask the question in English, in German, in Chinese, and Japanese. So, and then we have a front end that is hosted on AWS Amplify. It has a library called Alan Studio or Alan AI that can pick up our speeches. So we can just dictate, and then the Alan will transcribe that into English. So from the other languages, it will translate it into English, or English, it will just transcribe it to text. And once we have that question in English, we can send that question to GPT-3, which is a natural language understanding engine. So we can ask GPT-3 to translate the English to cipher, which Neo4j understand. And then we will send that cipher to Neo4j, and the query will return some results so that we can show the result again in the front end. And that is what you have seen in this previous slide. So that is the underlying the mechanic of the chatbot. And later, I have also added the pipeline that can extract new information from research paper. Surprisingly, it is also GPT-3 that does the heavy lifting. So it can extract relationships from the literature. And then I can import them into EC2 Neo4j so that the database can keep growing. So it's no longer static. So in the later development, the Neo4j knowledge graph consists of several databases. So the first one is the patient's record. So it is either from EICU or you have other patient records. But the public databases, for example, HaitiONet, CAC, and Strain are free medical databases. So they can be converted into a knowledge graph. So as long as we have that everything together, we can do cipher to query all of them. And in the GPT-3, what we do is we just need to provide some examples. So in this case, if I want to translate my English into cipher, all I need to do is to provide this 10 something English cipher pairs, as you can see in here. So the ciphers will be the English will be translated into ciphers. And then finally, you just post your challenge question, which the patient or the doctor will ask in the application. And then we just ask GPT-3, based on what you have learned, please translate this English to a cipher. And then GPT-3 will translate this English correctly into a cipher. That is the secret behind this whole natural language conversation. So we don't need to program every variation of English anymore, like in AWS Lex. Instead, GPT-3 will understand the semantic of our language and use the correct cipher template and construct the correct cipher. And then we can, query the database. That is what you have seen in this slide. So it will translate this into a cipher. So may I have a live demo of this?
Of course. Yes.
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 So as you can see in here, this screen, that is the
Yeah, perfect.
Doctor.AI's yeah, the interface. So let me ask Doctor.AI the question. For example, I want to ask what is the pathogen of cowpox. So it's like a virus infection. So I want to know what kind of pathogen it causes this disease.
Cowpox virus.
You can see here it is in the show mode. So you can see here in the bottom the translated cipher from this English. So when I type this and enter, this is what you will get from GPT-3 behind the scene, the cipher. And this cipher goes to the Neo4j. And Neo4j will, okay, match this pathogen to cowpox. And the answer is cowpox virus. And then you will see that the answer. And also, as you can see already, this example here, ELI5, because sometimes I want some simplified explanation of a disease. I don't want to, read all those medical jargons. So please explain simply what COVID-19 is.
Please write the information below.
So we get the the information from a major database called CAC, but that description is actually very difficult for non-professionals. But now, if we use the ELI5 function, also from GPT-3, you will have a simplified answer so that people can, okay, COVID-19 is like a pneumonia, but can cause also severe illnesses, and it is from the virus called SARS-CoV-2, and so on. And also, this whole the front end, actually, if you really look under the hood, is just a simple Neo4j database. So this is actually the database behind the whole Doctor.AI. So this is the schema, and as you can see, this schema
exciting.
is it's
Yeah.
actually quite, let's say, not very complex, but very it's like we have the information we need. So what is special is that actually all this part on the left hand side, it was imported from public databases. So there is a HateOnNet. It's medical knowledge graph that is maintained by a then PhD student and 6 years ago. So he has all these ontologies. So ontology, so like gene will be participated in this biological process, and this gene can cause this disease, and this disease happen in which body part, and so on. So which pathogen cause disease, and so on, and the diagnosis. So what we have added is, first we have enlarged this part because the HateOnNet is very thin on diseases. There are only like 140 diseases in the HateOnNet. And then I added the CAC database, which has increased the number of diseases to 2,000. So a large amount of this increase. And then this is the public part. So we have the, let's say, personal, specific, private part. There is the patients. So every patient, they can stay in a hospital. And then when he stay in the hospital, he will get a diagnosis from the doctor. And this diagnosis actually connect this patient into this disease. So as you can see, through this way, in this way, we connect the specific to the general. So we provide the context now to the disease, because every patient can have a very specific disease, but as long as it is connected to this general network, I can tell the patient more about his disease. If he has a genetic disease, then I will tell him what kind of gene causes your disease.
Mm-hmm.
And if it is infection, so then what is the pathogen? And what kind of drug can I use against this disease? So it's no longer like a simple medical record, but instead you can like have follow-up questions. So patient one has such a disease, and this disease is caused by what causes or pathogen, what kind of drug. So then you can have like a real conversation. So like a very human-like conversation with the Doctor.AI. And we hope that through this, we can also do something like a very simple diagnosis. Because as you can see in here, there is a symptom node. So which means if you have a disease, you should have some symptoms. So we can think the other way around. If I have some symptoms, can I know what kind of disease do I have? So yes, it is possible. So that is one part of our project is that we have use the symptoms, and then we ask with a match cipher, and then we get a list of diseases that contain all the symptoms that the patients complain about, and then also all the other symptoms that may occur if he has a specific disease.
Yeah.
Yes.
Mm-hmm.
So then the patient can just say, okay, I missed that. Maybe I can self-examine whether I do have the other symptoms. So yes, it's a very long list of diseases. You will have that. As you can see in the from symptom to mutations. So this is one of the possibility, one of the application of, for example, in this case, I have dyspepsia, weight loss, and fever. What kind of disease can I have? Then you will have the first possible disease is stomach cancer. Sorry, it has to be
horrible
foreign.
again. Yeah.
Exactly. But you don't need to say, okay, that is the hit.
Yeah.
Instead, you will go through the list and see, okay, it's possible because you have, because this stomach cancer have all the three symptoms. But then you will check, okay, so aside from these three, do I also have like asthenia, heartburn, and so on? So it is a way for you to like have just a self-diagnosis a process. So because I think one thing about medical, it is that sometimes people think, should I know that? Is it better that I don't know that? Actually, we are brave enough, so we are able to accept the truth. Just tell us the truth, and we can handle it. So it's better to have good and comprehensive information than try to we just try to hide the information. I think that is a better way. So just tell the patients what kind of possibilities are there. So, and let them handle it, let them design, and let them to also ask the professional for more information. And so this is how this is the philosophy actually behind this. So as you can,
sorry to interrupt, but I think it's also, it's not just saying, oh, you have potentially you have stomach cancer, full stop, and then it's it. But you get, okay, but check if you have these other effects also, or do you also have these other things, and then you realize, okay, maybe I don't have any of those. Then probably I might not have stomach cancer, but I might have something else.
exactly.
And I can filter it down some more, and have a bit more of a precise knowledge. Otherwise, I just see, okay, yeah, it fits, but here you get all these other additional information you wouldn't have gotten.
Yes.
From other, yeah.
So it's up to the patients, but
yeah.
that is the information we can gather and from reputable sources.
Mm-hmm.
So and also the genes. So for example, if a guy, because nowadays, as you know, that full genome sequencing, personal genome sequencing is more and more popular. So many people have their full genome sequence, and they can know what kind of mutations they have in their genome.
Mm-hmm.
So there are many gene like mutations that can lead to diseases. Not necessarily, but sometimes you are a carrier of a defective gene, or you will have certain risk of carrying a certain genetic disease. So it is also possible now in Doctor.AI, because if you have this certain kind of disease, and then we can ask what kind of possible genetic disease you may have. So,
mm-hmm.
For example, here we have a patient, let's say anonym ID3. So, and then this patient, does he have any genetic disorders? So, and because this ID3 patient has a mutation in a gene called CAT, and it is known that this mutation can lead to certain kind of genetic diseases. So, for example, this can lead to a Christiansen syndrome. So it's like not only the patients but also the doctors. Doctors are also human, so they can't.
You cannot know everything. Yeah.
Exactly. They are not necessarily an encyclopedia. So if you have information like an AI that can help you, so because that combines both the characteristic of the patient and the medical knowledge together. And so
mm-hmm.
in this case, the patient has this mutation, and in the literature, this mutation lead to this disease. And then this AI can bring this together and then present it to the doctor. So to help the doctor to know more, to help him make better decision and diagnosis.
Exactly. I know. I mean, what this could also mean is like you just said, better treatment, better pick of a medicine. Let's say you know that your patients are allergic to something or have a predisposition towards something, and then you can subscribe them one medicine or the other. And if then the AI gives you a recommendation, says, hey, this patient is let's say allergic to something that is part of this certain medicine, so rather give the other one, then if you treat lots of people every day, you might not remember everything about every single person you're treating, and then you might forget about this, and then
Exactly.
yeah.
Because also it is helpful to offload some of your memory and knowledge onto the other medium to free your mind, so you have more capacity to do creative thinkings and to focus on the more urgent issues instead of try to dig up the Asian memory, and you can be wrong because your memory can be faulty, and eyewitness can make false statements. But if you have like electronic immutable record in your database in Neo4j, and then this chatbot can bring it up in split of a second, and then you won't make these costly mistakes. And then what you mentioned actually is the so-called personalized medicine. So maybe both patients will have the same disease, but they will receive different medical cares based on their own physical characteristics. So maybe one guy has a specific gene mutation that has some susceptibility to some medicine, as you have said, and the other guy doesn't. So they will receive maybe even not the same medicine, or the same medicine but different doses. So so we can store this information hopefully later in the database, because that it will help us to first we will keep the whole patient records in this part of the database while we keep updating this the general medical knowledge. So both of this part they will evolve. So they are not static. So, and with more and more data, as you have said, we can even do some machine learnings. So, for example, there is one is ongoing is to repurpose the drugs. So you have here it's so-called compounds in this case because a drug belongs to compound. One possibility is that if you have enough connections and data, it's actually possible to use an old drug for a new disease. So that involves some graph machine learning. So that is something we also hope to do in the future with this GDS from Neo4j. So to do some link predictions. So if you have several, so a very simple example is just like a movie recommendation. If all your friends have seen that movie and your taste is like your friend, you may also like the same movie. The same goes to the patients. So if all the patients with similar conditions receive a certain treatment and the treatment went well, then you may benefit from the same treatment. So it's this kind of collaborative filtering. So to predict linkage in this case, or we can also predict the node's properties. So whether this patient may have some other disease, not only this. So like if he has certain kind of syndromes or certain kind of vitals, so also the lab readings, is it possible that he will have other conditions? So yeah, that is also possible. And as you can see, it is very elegant. Everything, it is inside just one graph instead of thousands of SQL tables.
Yeah, that's very elegant indeed. What you just said about the compounds and the medicines is very crucial, I think. With new old medicine helping out with new diseases, lots of new new illnesses might come up or will be discovered, and then if you have something ready, if something helps towards a certain disease, then I think that's a super interesting knowledge, and then that will hopefully help the patient's way towards getting better quickly.
Exactly.
Yeah, without having to do develop everything from scratch. I think I remember when COVID was in its height, there was also this debate about what do we currently already have which could help, maybe not perfectly, but at least help make it not as bad as it is when you have it, and help towards the patients getting better more quickly.
And because also the development of a new drug costs enormously.
Yes.
Especially in the recent times, so like in billions. And then if you can repurpose an old drug, however, it depends. It again comes into the ethical issues because, for example, in the FDA, they will have a very strict guideline saying that this drug can only treat this disease. So you can't say, okay, this drug is also good for an disease XY. You can't just say, okay, I will use it for XY. No, it is not okay. So with the FDA. So, but at least if we can provide evidence that it may help, then it certainly is good to let people know, and maybe that is the first step towards the repurpose. So it is like a first hint. Not
exactly, and
necessarily saying, you can do it tomorrow.
Exactly, like you said. I mean, it takes a lot of time and a lot of money to develop something from scratch. If you have something that research now points that, okay, this could help for this other disease. It's not approved, but okay, we can start with a already existing product and then do some research, some testing, and realize, okay, actually it works.
Exactly.
I mean, that saves you months and years and millions of dollars in money.
Yes. So I want to just very shortly show the front end, how actually the thing comes together. So this is the back end.
Yeah.
So because you said, yeah, let's have a small code section that to see behind the curtain. So actually, the whole front end thing, it is a chatbot that we use from the React Simple chatbot. It is uh, open source project from GitHub, and then it is a very generic chatbot, and then everybody can use it to develop and program their own chatbot. So we use that simple chatbot and then just to plug in our things. So yeah, so because the original chatbot is a very it's a programmatic chatbot, so it will program what it will respond to. For example, if you say hello, he will just say, hi, how are you? So it's like yeah, it's like a programmatic way. But in this case, we need Neo4j, so because that is our backend. So we will have everything like the normal stuff. So a driver, and so to connect to our Neo4j backend. But crucially, in our case, we will have a GPT-3. So this GPT-3 actually does all the heavy lifting for the natural language understanding, including the foreign language to English, English to Cipher, and so on. So we need here, in this case, the OpenAI API. So that means you need to have an account from OpenAI. And what you have seen in here, so this is not GPT-3, but GPT-J very similarly. So how GPT-3 works is that you need to provide like a header. It is an example section, basically. So you provide a lot of examples. There are maybe 10, 20. The cases you want to cover. So what is the English and what kind of answer you want to expect from this English? That's it. But this is the playground. You need to do it programmatically. You just need to copy everything in here and then fill it in the, it's not the, yeah, the magic in here. So we just need to have like a variable that's have all these training headers, the training pumps. And then every English will begin with a sharp. So, and then you will have your English, and then you can even program some of those so-called rephrases. For example, if you want to ask ELI5 what is lung cancer, but you can also ask it in a different way. For example, explain lung cancer in simple way, or explain lung cancer in plain English. And then you can train them up with a semicolon. So then GPT-3 will understand, okay, so it doesn't matter how you ask, even you ask something, the same question with a little bit variation, GPT-3 will get your intention and it will give you back this cipher. So this is the training header. And then this is the trick. We leave another sharp here to receive the English question from the user. So then the user will enter their question. So in this case, in the search variable. And then when we have this English question, we will join this training prompt and the English question from the user together and make the query variable. And once we have this query variable, we can just send it to the OpenAI GPT-3 with this DaVinci 002 engine. So with all these parameters and so on, you will get a response. So in this case, we will get the cipher. Yep. So in this case, if we want to ELI5, we will do something else, but otherwise we will just accept the original cipher. And then when we have the cipher, things get easier because then we can just say, yeah, let's just send the cipher to the Neo4j. That's here. So basically, this is the session await session run. That is the cipher, and then the rest is the usual Neo4j result pass stuff. So you just go through the results from Neo4j, and then you will get the response basically that you want to present to the user, and then you just you just make a an utterance or something, and then you just put it back into the React front end. So you do like a set state and upload the component on the on the chatbot. So that is basically what you have seen in here. So yeah, that is basically the whole inner working of the chatbot. So you just put two things together, Neo4j and GPT-3. And the translation, and so it is actually nearly the same, except that you need an instruction. So for example, in translation, you will say, please translate this into English. So in this case, translate this. So target language, sometimes if you speak German, then this language, target language will translate this German into English. And then it will go to this library, and then it will get this instruction, and then the German language question.
Sorry, Session. We see
Yes.
the Doctor.AI screen. We don't. Do you have a second screen open for this now?
Okay.
Or no?
Sorry.
Yeah.
So sorry. So do you see the?
Yeah. This. Yeah. Okay. Now we see. Yeah.
Okay. Sorry, the previous session. So this is the header.
Okay. No, I did. I did.
Sorry.
Because you had the other code open, and I thought, okay, this is what you were talking about. But now I see. Okay, you had this. Here.
Okay. So just very short. So again, so this is actually the core function, the core script of Doctor.AI, the component, the JS file. So you need two components, basically the Neo4j, in this case, the driver and so on, connect to the backend, and then the OpenAI API. So as you can see in the demo in the playground, the GPT-3 works with a header session with all the examples. So in this case, I hard-coded in this JavaScript, and then at the end of the prompt, I just leave behind a sharp. And then this sharp indicates we are ready to receive the user's English question. So the user's question will be stored in search. And then if we don't need here the translation, we will go further. And then the whole thing is that we will connect, we will fuse, we will merge this header and the question. So we then get the variable query, and that is what we need for GPT-3, because then this query we will send to the GPT-3 API, and then we will get the response in from GPT-3. So we will get the original response. So in the first case, it will be the cipher. So we will have the English. The English will goes in here, and then we will get the response. It is a cipher. And then once we have the cipher, we will just say, then we just send it to our backend. So this is the line in here. So section 1 cipher. And then the rest is we just pass the output from Neo4j and then present it into the front end. So as you can see in here, the text to speak is the results, and then we just now need to set a state and maybe even spit it out. So in a human voice. So actually that's it. And if we have a foreign language, we just need to translate that foreign language into English, saying, please translate this German into English. The same goes for the ELI5. So it is basically the same function, except you will have a different instruction. So if you want to translate, you will tell GPT-3 translate this. If you want to ELI5, you say please ELI5 all this complex sentence. And basically that's it. Actually, that is all components I need for the core function of Doctor.AI.
Yeah, super cool. And you basically go via English for that, and I think that's. Do you think that could that
So you
be?
can currently you can do it in English, German, Chinese, and Japanese. So the language that I can evaluate. So you will have the localizations. So you will have everything in the local language, and so but the quality differ, I have to say. So German to English is good, while Chinese to English sometimes GPT-3 will make some translation error, which is not very good in a medical case because you want everything to be precise. So currently, still because GPT-3 is still an English mainly in English, and our knowledge graph is also in English. So it's very hard for us to say develop like a German chatbot completely. So everything in German, the knowledge graph in German, and the response also in German, because it will mean that for every language we will need a dedicated team, language experts. But if GPT-3 can translate everything back and forth into English, that makes the development easier, but we need to pay attention to the translation.
Yeah, definitely. That is often not great, and then, like you said, particularly in a medical background, if then there translation errors come into play, then it could definitely lead to misunderstanding or even wrong things. But I mean, like we said in the beginning, this is not supposed to replace an actual doctor. So this is just a helper for patients and for potentially patient-doctor interaction. So there is always supposed to be an expert together with the user. So they will then have to obviously sanity check some of the results and say, okay, well, this is probably now an error, and we might have to try it again in maybe in English in the first place. But you know, it's cool that it works like that already, and you get very far along the way with this, and I think that's what the main point of this all is, right? That it is possible, and how quickly and how easily it can be achieved.
Yes. So as I can see that in the discussion, are we trying to deploy the chatbot in other languages? So yes, as I said, there are two ways. Either we rely on GPT-3 to do all the translation, or we have for each language a dedicated team to make everything local. So the database local, the dialogue local. But the first one is easy, however imprecise. The second one is expensive, precise. So there is a trade-off. And as I know, there are already some of my friends in the Nordic countries, they are already trying to have their local version, and maybe even in Israel. So they may have their Hebrew version of the chatbot. And I want to emphasize one thing. Let me show you the screen again. So just one final thing. Actually, the whole chatbot, it is just one way to implement this. I mean, it's more like a framework. It's not like this is the definitive solution to the whole thing. If you don't like any component, you can switch it. So it's more like a proof of concept in this case. So I use Alan as the dictator, the speech transcriber, but you can also use Google speech to text, and you can host the front end on Firebase. And if you say I don't like GPT-3, you can use GPT-J or maybe the Facebook. They have also released a new NLU, and you can also put the database on GCP, or you can use some other SQL, whatever. You can put also other data into the database. So basically, you can change the components or even the content of the pipeline. This demo is just like one concrete implementation of this concept. So yeah, I'm very curious that how people can also do it, maybe with other means to, or use it in other domains. And I think the principle should be the same. It is to give the greater population access to the powerful knowledge graph, so that they don't need to program, they just need to speak. And the GPT-3 can make the development very easy. So you just need to provide this header. And yeah, basically you just need to provide this header to cover all the conversation cases. And also very amazing is that GPT-3 can learn. So if you find out that GPT-3 makes a mistake, you can add the correct answer back into this training box.
Yeah.
GPT-3 will correct it in the future. Actually, yes. So as long as you keep updating you keep monitoring the performance and so on, and so both the data and the accuracy of GPT-3 actually will improve. So the system actually will improve over time with use. So if you have more users, you put more effort into updating literature. So it's a very good cycle. So like a virtual cycle, more people use it, you get more data to correct the mistakes, and then you get also more feedback. So that is how we position this and conceptualize this.
Cool. Yeah, I couldn't agree more. I think that's a great aim and a great goal for a tool like this, to have it accessible by as many people as possible and used by as many people as possible. So that's really great. No matter the the exact stack, how it's set up.
Exactly.
We have maybe one more question from chat, or actually there are two from chat here that maybe we can quickly go over.
Yeah.
Nengo Koba asks, could you share the knowledge graph source as well? I don't know.
Yes. There is actually I provided it as a dump, so Neo4j dump, and you can import it into your EC2. In this case, you can also use it in your Neo4j desktop. So it's amazing that the Neo4j desktop version is enough for the whole project. So yeah, even though it is like everybody knows it is only 4 CPUs and memory limitation, but still in this scale, you can use it. However, I have to say one thing, because the original EICU data, it comes from the medical school, I think from MIT. So in order to get access, you need to go through a course, an ethical course. So you will have the link. So it will tell you the material you need to go through, and then you need to learn how to respectfully use this data, and then you can download the full version. So in that case, I cannot provide the EICU data, but I have some dummy data. So you don't need the EICU for the playing. So I have some dummy data, and actually there is a great resource for the patient data too. It's called Cynthia. So basically, it is just like a patient simulator. So you can generate as many patients
Okay.
as you want.
Yeah.
Actually, you can generate 1,000, million, and they will have address, they will have name, they will have a disease, and so on. And then in one of my article, I also say how can you use that stuff to further develop the chatbot.
Okay, cool. I think, yeah, I see it. So yeah, if you I'll post a link to your original article again in chat. So that's the first that started the Doctor.AI series of your blog, and then you can follow. It's 10th article now, talking about GPT-3, and Cynthia was one of the previous ones.
Yes.
So you can, if you want to know more, read up on the full development cycle. Recommending you to go into the article here.
Yes.
Yeah, exactly.
So I have given you the link in the chat. So I don't know how can I post it in the public, but yeah. So Alex, please. Later.
I'll post it in chat.
Thank you.
Yeah. Where is it gone? Here we go.
May I make one small addition? So
yes, of course.
Yeah. So maybe it will be interesting for some. Because I mentioned that how to update the database, and then so as you can see, we can actually use GPT-3 to do other stuff, not necessarily translation, but also extract relations. So let's say if you have a sentence like this, SCD1 is upregulated by blah blah blah. And then you can send this sentence actually to GPT-3, and GPT-3 will be clever enough to extract the subject, SD1, the verb, upregulate, and the object, by which gene. Of course, we need to add some other components before, because GPT-3 costs money. So you want to be precise. So you don't want the whole PDF goes to GPT-3. So you need to kind of do something pre-processing, like split the sentence and filter the sentences. But the most difficult part is the GPT-3, and GPT-3 does it excellently. So once you have this relationships, you can just go to the RRDB, import them, like in this case in here. So actually, this is a live example, example to that all these relations come from a research article. So I can just extract those data, so in natural language, and then import them now in Neo4j. Of course, it's a simplified version, but in the production, you need to take care of the entity disambiguations and so on. However, the performance of GPT-3 in the extraction is very good. And so I think one major difficulties in NLP is how people can accurately extract these relations. And I think GPT-3 is a very interesting candidate for this task. So so please try GPT-3 in the NLP pipeline. Yeah.
Yeah, and I mean, what you just said now is probably very interesting, because all this research and all these publications that are like a huge treasure trove of information that is almost inaccessible to an ordinary person. Nobody is able to read all of that. Nobody is able to understand what's going on. So if you have an AI crawl through all these texts and then eventually pick out the keywords, go through them, and then filter them and say, okay, yeah, for your query, these are the top articles, or this is the research currently that you should look at, and then it's very helpful because
Exactly.
it gives you like a a better guidance and a better story towards towards a treatment.
Yeah, and we plan to do it like systematically. So as long as you have this raw text, we can go through it. So I have to stress that this is not the only pipeline. Actually, many people are doing it. So like in the Harvard Medical School, they have a pipeline that integrate many tools into the NLP pipeline, but they haven't tried GPT-3.
Yeah.
And in this case, GPT-3 is like, yeah, it is very simple to use, and the development time is very low. So it would be interesting to have yeah, to add that, to try that actually.
Yeah, absolutely. No, we don't say this, but it's an example, right? And it's a way to go about, and obviously, and we haven't touched this during this session, but I guess it is goes without saying. But obviously, patient data and all these personal things, they need to be secured. They need to be probably be very storedly saved and all of that. This is just an easy example how it's technically feasible and how it can be executed and how it could be implemented. Obviously, if you do this as an expert and as a professional, patient data and patient information need to be locked away and need to
Yeah,
be very tightly secured. So, you know, but it's not the point of this showcase today.
yeah,
It's supposed to be you know, understandable and how quickly and how easy it can be done. Obviously, if you productionize this or if you put it somewhere and people can access, you don't want to know the last query your neighbor asks. So really, it needs to be
exactly.
it needs to be safe. Yeah.
So you actually mentioned a very important point. So like I said in the other occasions, we have the tech, but we don't have the ethic and the legislation. So
Mhm.
even you have a chatbot like this, no country will say, I will use it tomorrow.
Yeah.
Even though you can, yeah, you can implement it maybe overnight, but how can you, because the patient advocate will say, how can you safeguard my data? How can you say, just like you said, how can I don't ask your patient's record? How can the doctor ask everybody's record? And how can you make sure that it's not hackable, and so on? So that is not, in this case, not our discussion. Instead, we just provide that what is possible right now, and we let the decision maker to decide, yeah, how to, yeah, like you said, in production, it is not look like, it doesn't look like this. You need to provide several layers of securities and also access controls and so on. But this is the bare bone, let's say. And also you can use it for other projects. I don't mean you can only use it for medical. You can even use it for your research project and add a chatbot in front of your knowledge graph. And yeah, you don't even need to write a cipher again.
Yeah. Yeah, exactly. I mean, it's if you don't touch sensitive data, then it's all
Yeah,
it becomes very easier and less less difficult to handle. This is obviously the outlier case of maximum security where it's needed, obviously for patient data. But yeah, if you are into doing you know, some kind of manufacturing or other use case where a chatbot could be set up, you
yeah,
don't have to worry about customer or patient or whatever data. Then, you know, easy and very quick.
yes, I agree.
Cool. All right, I think we almost we know a little bit over time, but there's no worries really for today.
Yeah.
Just wanted to close it down. Thank you very much, Xing, for taking the time, for guiding us through, and for actually for showing us the back and the front end of Doctor.AI. Was
Thank you.
super exciting. I enjoyed it a lot. If people would like to know more and get in touch with you, I guess um, subscribing to your Medium blog is one thing, or following you at Twitter at DGG32.
Yeah.
Any other ways? Any other things you'd like to mention where, you know, where people can get in touch with you or follow you or read more from you?
I am also online in LinkedIn and the usual social medium. And one particular thing, actually, I love to hear the stories from all you guys. So not only the developers, but also the audience. So you have the experience and some very nice experience, good stories along the way. So if you have knowledge graph or you are working in the medical, so tell me the stories. So your success, your failure, and I will be very curious.
Yeah, absolutely. That's cool. Cool. Well, yeah. Thank you, Xixing, for presenting. Thank you all for watching, and hope you enjoyed it as much as I did. We will be back on Monday with Michael and I on the next Discover ORDB session. Until then, I wish you all a great rest of your week. Stay safe, everybody, and speak to you soon. Bye bye.